When we picture a genius, society relies on a very specific archetype. We imagine a loud, rapid-fire thinker who instantly solves complex equations and constantly proves they hold the most facts in the room. But look at this diagram. For decades, popular culture has treated the brain on the left like a hard drive, assuming high intelligence means possessing massive storage space for data. Cognitive scientists, however, view intelligence much more like the model on the right, a highly active processor constantly making connections. Because extreme intelligence is built on processing rather than simply storing information, it rarely looks like showing off. An active engine doesn't need to constantly project its output to the world. Instead of loud displays of dominance, highly intelligent people often display subtle, quiet, and seemingly awkward everyday habits. We can map these quiet habits directly onto the biological pipeline, tracing exactly how a high IQ brain processes reality from the moment it wakes up. By discarding the myth of the human hard drive, we shift our focus toward a different set of behavioral markers to identify the smartest people in the room. This model breaks down the cognitive pipeline. The first stage, illuminating right here, is input. Before a highly capable mind can solve a problem, it aggressively gathers raw data from its environment. This phase manifests as a state of constant curiosity. Highly intelligent individuals don't spend all day pondering grand philosophical mysteries. They interrogate the mundane mechanics of everyday life. They want to know why a specific system operates the way it does, pulling apart their surroundings for new information. In social settings, this translates into observing far more than speaking. Before engaging in a conversation, they will silently analyze the room's emotional cues, assessing group dynamics and individual behaviors. They do this through a biological mechanism called pattern recognition. The brain is invisibly scanning the environment to predict behavior before offering a response. People often judge this intense silence as shyness or skepticism, but it is actually a period of aggressive, precise data collection. Once the environment is scanned, the collected data moves into the sorting mechanism of phase 2, processing. This is where the heavy internal work happens. Managing that massive volume of input requires strict isolation. Research from the London School of Economics shows that highly intelligent individuals actually report feeling less satisfied with life when forced into frequent social interaction. Look closely at this glowing quadrant, the prefrontal cortex. This is the region responsible for complex planning, reflection, and logic. To handle an overload of new data without overheating, this brain region requires a physical buffer of quiet space. When they are alone and the processor is running hot, you might catch them talking out loud to themselves. Psychologists refer to this as self-directed speech. It physically strengthens working memory by forcing the brain to vocally organize and sequence its own thoughts. You will also see them agonizing over tiny, seemingly insignificant details. From the outside, this looks like crippling indecision. Internally, it is a single brain successfully testing a dozen different mental models simultaneously. And because this engine rarely shuts down easily, the processing often bleeds deep into the night. Evolutionary psychologists point out that this preference for late-night thinking is a biological adaptation, allowing highly flexible minds to thrive outside traditional, rigid daytime routines. It is easy to write off isolation, overthinking, and talking to yourself as neurotic traits, but when a biological system runs at this high of a speed, these awkward behaviors are mandatory maintenance. All of this quiet calculation ultimately feeds into phase 3, output. The sorted data translates into external reality and action. One of the clearest indicators of a high IQ output is the speed at which a person will change their mind. When presented with entirely new evidence, they drop their previous stance immediately. Psychologists identify this trait as cognitive flexibility. Highly capable minds treat their beliefs as flexible, temporary tools rather than fixed identities. If a mental model is broken, they update it instantly, leaving their ego completely out of the process. This capacity for rapid updates also drives an advanced sense of humor. Creating a joke requires the brain to identify a social pattern, anticipate an expectation, and then instantly bridge two unrelated ideas to subvert that expectation. It is cognitive flexibility in a social form. But perhaps the most counterintuitive output is hesitation. This chart illustrates the Dunning-Kruger effect. Notice how, as an individual's awareness of a subject's complexity increases, their outward confidence plummets. They grasp the limits of their own knowledge, making them comfortable saying the words, "I don't know." True intellectual output is characterized by adaptability and a healthy comfort with uncertainty. It is the opposite of the loud, unyielding confidence we have been trained to look for. When a cognitive engine runs continuously, gathering data, processing in solitude, and adapting to new evidence, it inevitably turns outward to the largest questions available. A heightened awareness of how complex society truly is leads directly into deep, quiet reflections. They constantly examine purpose, identity, and the intricate reasons why human beings make the choices they do. So the next time you interact with someone who slips away to be alone, who mutters to themselves while working, or who hesitates before answering, pause before making a snap judgment. These moments of isolation or hesitation are the visible exhaust of a high-speed processor, the side effect of a brain operating at a different frequency than the social world around it. Ultimately, intelligence manifests as a persistent curiosity, an engine that keeps exploring why we think, feel, and behave the way we do.